Assalamualaikum, I'm Saim. In this video, I'm going to discuss about introduction to parallel and distributed computing in deep learning. As deep learning systems are computational hungry and require more computation power, so we need to come up with the computing techniques which are best for resource utilization and efficient in computing. So the parallel and distributed computing techniques give us the way in which we can train the deep learning models in efficient manner. So starting with the parallel computing, what actually it is, parallel computing take the task and divide into subtasks. Now, when the problem is divided into subtasks, it is these subtasks are going to pass to processor, and processor start executing it, and it gives us the view that it is executing all the tasks at the once, but behind the scene it is executing the single task at a time. So it gives us a view that all the tasks are simultaneously executing. The modern computers have the multiple processors in their system, and these processors are sometimes referred to as cores. And what is like behind the scenes performing that we are taking the problem, we are dividing into the smaller chunks, and we're executing that chunks into the processor. So it gives us a view that all the tasks are executed at once. The distributed computing is just like the parallel computing, but it is also dividing the tasks among the systems. But in parallel computing we have the single machine, and inside single machine all the processors are there. In parallel computing there is a single machine, inside single machine there is all the processor, and these processors are executing the task. Whereas in distributed computing we have the multiple machine, and each machine have its own processor, and the task is distributed among all that processors. So these are the two basic type of the computing execution scenarios that we have seen. So deep learning, coming to deep learning is just like uh, the subfield of artificial intelligence and machine learning, and it is actually mimic from the human brain. In human brain there are billion of neurons. Each neuron is like just single entity, and there is billion of neurons, and these neurons are connected with each other. And when we receive some certain information, whether in the form of image, sound, or touch, uh, these information is going to be passed through our neurons, and our brain is able to uh, judge something or make the decision. So scientists adopt this technique and say that just like we have deep neural network, why we not create a deep neural network in which there are multiple neurons are connected with each other, and these neurons do some computation, and after that computation we can generate some kind of results. So the small circle that you are seeing here are actually the called the neurons, and every basic neuron has a basic neuron or the neural network we could refer to as this whole structure in which different neurons are connected to each other. And it has three part. So an input layer, multiple hidden layer, and the output layer. So what input layer is doing, we are just converting our data, just like we have image or the sound, we are converting that into numbers, and these numbers could be in the form of array, and these numbers are going to pass through this input layer, and this input layer take that numbers and pass to multiple hidden layers. Now these hidden layers are some time of computation machine, you can say that, and in that there's a function at each neuron is associated. So what it is doing, that it is performing some kind of computation on that function or the mathematical equation and passing to the next layers. So there are multiple hidden layers that are connected with each other, and after that the result is generated at the output layer. Now the output layer convert our numbers that are computing from the multiple hidden layers in our desired format, so we can understand that. So this is the basically a normal feed forward neural network architecture. It look like a simple, but it requires a heavy computation power. uh, so this is the very simple and basic architecture that we have seen. Similarly, as the time passed, the multiple deep learning architecture came into the market, and the current one is the transformer architecture, uh, based on which we have seen the current chat models like ChatGPT or Gemini. They are using the transformer architecture behind the scenes. Now, the ChatGPT and Gemini are using the transformer architecture, and the transformer architecture really requires a lot of computation power, because we are passing a bunch of data into the our neural network, you can say that. And there is many computations are behind the scenes are performing, and but the underlying basic structure is like this neural network. uh, on on the top there are different architectures that are made. So why we need parallel and distributed computing? As many time I mentioned earlier, the neural networks are very computation hungry, and the tasks that we are executing using neural networks are really computational expensive. So we need to build a such system, or we need to train our model on such system, by which we can make the execution in more efficient and powerful manner. So the distributed uh, parallelism is there's a term which is referred for the training deep learning system is distributed parallelism accelerates accelerating deep learning. So in which we are there are multiple machines that are connected with each other, and the processes are connected with each other. And what we are going to do, we are going to perform two things on it. We are dividing the data and giving to multiple machines, or we are taking the machine learning model, just like previously we have discussed about the neural network. We are taking that and passing to the multiple machines, and multiple machines are going to perform the computation based on that. So in distributed parallelism is referred to as we have multiple machine, and we are taking the task, giving to that machines, and each machine is performing parallelism on its behalf. So there are two kinds of parallelism that we have in distributed parallelisms. So data parallelism and model parallelism. So distributed parallelism have two types: data parallelism and model parallelism. In data parallelism, we take the dataset and partition it and pass to multiple nodes. So taking the data set and splitting into batches, and these batches are going to be in the multiple worker nodes are working can be nodes can be referred to as the GPUs. And the underlying structure they shared with each other is the shared memory architecture. The reason to use shared memory architecture is that we have the batch one, and we have the node one. So once the node 1 is trained on the batch 1, the next time the batch 2 can be passed to the node 1, and similarly the batch 1 can be go to the node 2. So the batches can be exchanged with each other on the different nodes. This is just because there is a concept that is used in the machine learning is training and training, testing, splitting. So we take the 80% of data, we give it to the model. Once the model is trained on the 80%, now we can give the another 20% to test the model. Now this 20% can be from the first batch or the second batch or the third batch. So the batches are always changing. So when the batches are changing, we need to shift these batches to different worker nodes, or to different machines, to different GPUs, or maybe to different models. So when they are shifting, so we need a shared memory architecture so they can accessible for the every other worker node. Similarly, in model parallelism, we take the single model and uh, we take the models and we ran that model on different worker nodes. So we have the now the shared data. We have different worker nodes, but the memory for the model that you are seeing is the distributed memory. The reason for this distributed memory is that we can have the multiple training parameters. Now with every model, the parameters are associated with it. So when we have the multiple training parameters, and we need to store them in distributed manner. So maybe the model on working node 1 is trained having less error or more efficient parameters than the model on working node 2. So in this way we need to have the distributed memory. And another thing is that when we have the multiple models that we are training, every model have different size. So when the every model have different size, is it needs different kind of memory sizes. So that's why we preferred the distributed memory in the model parallelism. Now there are the tools and the framework that is used for the distributed computing is PyTorch, TensorFlow, and Harvard. TensorFlow is utilizing the TPUs as known as tensor processing unit for the parallel and distributed computation. And similarly, the PyTorch is utilizing DDT, which is kind of distributed data parallelism, in which we take the data set and we divide it, and the PyTorch gives us some kind of functionalities or the functions, you can say that, by which we can easily execute that data on the multiple machines. So, what are the benefit of distributed parallelism deep learning? That it makes the training faster. Of course, when we have multiple machine and we split the data and we are executing on the many of the machine at the same time, the training process is going to be much faster, and it's scalable. In it is scalable in two ways, like in data and as well as the machines. So when we have the single machine, we can execute the task on it, and we can add the multiple respective machines after that when the pipeline is created. Similarly, when we execute the task on the single data set, and after that we have the multiple data sets, so we can give that data set to multiple machines, and we can add multiple data sets to the multiple data machines, and we can execute the task. In this way the resource utilization is done better, because we are not just leaving every machine freely. We are giving some task to it, and it is executing that. And the large models, just like BERT and other kind of model, cannot fit into the single memory. So maybe we can have the two memories and the two distributed memories, and we can take that distributed memory and pass to the single worker node or the two worker nodes, and it can execute the task. And it also improve the efficiency of the training of the deep learning systems. Now there's image classification with distributed GPUs. So we have kind of the data set. It is the example that is explaining the data parallelism and model parallelism, and we just divide that data set into patches. And similarly we have model, and we are passing that data set and the models to the GPUs, and GPUs are actually performing the task, which are the most computationally powerful machines that we have right now in terms of classical computing, and the results are going to be stored into the CPU at the end. So that's all. Thanks for